Example 4.2b is asking us to find from first principles the derivative function for the function 3 on x squared. In fact, in your notes, it's listed as g dash of x and g of x. Before we go any further, we need to write out g of x plus h, and that equals 3 on x plus h squared. Now, because this is in the denominator, there's no need to expand. Okay, the reason that we don't need to expand is because we're not going to try and factorize h out of the denominator, because h is already factored out of the denominator as part of the rule. So g dash of x is going to be the limit as h approaches 0 of g of x plus h minus g of x on h. Now, something else to consider, because both of these are fractions and we're going to put them into the numerator of another fraction here, we're going to actually pull out this factor of 1 on h. So instead of writing the h in the denominator like that, I'm going to put a factor of 1 over h here, which will act the same way. And then I'm going to do g of x plus h, which is 3 on x plus h squared minus 3 on x squared. So we create a single term inside the bracket by cross multiplying. So we'll have 3x squared minus 3x plus h squared on x squared x plus h squared. Don't expand the denominator because we're not cancelling anything there. What you should do now, though, is expand the numerator and cancel what can be cancelled there. So we've got 3x squared minus 3x squared minus 6hx minus 3h squared, all divided by x squared times x plus h all squared. You can see that the 3x squareds cancel each other out, and remember our check that everything that's left should have an h in it, which it does. So the limit as h approaches 0 of 1 on h is minus 6. In fact, I'll factorise out that h now. There is another factor. There's also a factor of minus 3 between these two terms, but don't factor out the minus 3 because we're not going to cancel that with anything. We're only going to cancel the h, so that's the only factor that you should be pulling out. So it's going to be h outside of minus 6x minus 3h on x squared x plus h all squared. Now we can cancel our h's, and we are left with the limit as h approaches 0 of minus 6x minus 3h on x squared x plus h squared. There's nothing else to cancel in the denominator and the numerator, and if we substitute h into the equation, there is an h in the denominator, but it doesn't cause the denominator to be undefined, because x plus h, when h is 0, is x plus 0, which is just x, which is x squared. So we don't have to cancel absolutely everything out of the denominator. We just need to cancel to the point where subbing in h equals 0 no longer causes the result to be undefined. So from here it's going to be minus 6x minus 3 lots of 0 divided by x squared x plus 0 all squared, which leaves us with minus 6x on the numerator. In the denominator, x plus 0 is x squared times x squared is x to the power of 4. Now, because we are good mathematicians, we recognise that we have x's in both the numerator and the denominator, and we cancel out one of those x's, top and bottom, and we're left with negative 6 on x cubed. Therefore, g dash of x equals negative 6 on x cubed. And that's it.